are out there what they think the best way to go about doing this one is? Yeah, Brendan.
Well, you can separate it.
You can separate it? What do you mean?
So you can make it
integral from
integral of
1 to e of what?
Yeah, so x squared over x minus 1 over x.
Yeah, so you're just doing how many integrals?
2.
Exactly. And then is each one of those rather straightforward?
Yeah.
Yes. Not e, sorry. It just turns into x dx minus, and then what's the integral of 1 over x? Ln x, and we're going from 1 to e, so you just have to make sure you subtract that thing. So then you have 1/2 x squared from 1 to e minus, what's ln of e? 1 minus what? Ln 0, right? So what do you have here? E squared over 2 minus 1/2 minus 1. I think I'm doing this right?
Yep.
E squared over 2 minus 3/2. Is that one of the possible answers?
Yeah.
Minus
3 over 2.
Which one is it? Is that e? Yeah, there we go. Cool.
That's neat.
So the slope of the line tangent to that curve. So what kind of differentiation do you need to do? You need to do implicit differentiation. So if you implicitly differentiate this, what's going to happen? It's going to become what? 2 what? 2y. Yeah, y. You could say y prime, sure. Plus 3 xy plus 1 to the 2. But then you have, what goes right here? What do you have to use? You have to use the product rule.
Yeah.
You have to use the product rule here because xy, treating y as a function of x, so it's going to be x. So the derivative of the first times the second plus the first times the derivative of the second, right? We good?
Yes.
We're applying the chain rule, but inside the chain rule we needed the product rule. And what's that going to equal? 0, yeah. It's just constant at 0. It's not going anywhere. 0 stays 0. So now what do you plug in here? Do you need to isolate y prime here? No. What could you isolate y prime if you wanted to? But you don't need to. It's not asking you for the general equation, right? It's asking you for this numeric value of y prime. So take the easy way, which is then you just take this point right here and you plug it in, and then you have a bunch of numbers, and it's a lot easier to simplify. Does that answer your question, Jesse, about how to do this one?
Yeah.
You can finish it on your own. Great. X squared plus y squared is equal to 4y. Oh, look, x squared plus y squared minus 4y equals 0, correct? Oh, I could, if I really wanted to, add 4 to both sides, right? So what do you get? X squared plus y minus 2 squared is equal to 4. So that's a circle, radius.
Where did the y minus 2?
Oh, what did I just do? Complete the square! Did I just do that today in Algebra 2 land?
Yes.
Complete the square. So this is a circle radius 2 centered at what point?
0,
0, 2.
Centered at 0, 0, 2, or is it, what is that? Centered at what?
0, 2.
0, 2. Right. So what does this look like if you were going to actually draw this? It's centered at 0, 2. There's your center, right? So what does this thing look like? Looks like that?
Yeah.
So this question asks the area of the region inside the polar curve, r equals 4 sine theta, and outside. So what are we actually doing here? You're looking at this region right here. You're looking at that region right there, right? Now here's the thing. Theoretically, do you have enough information to do this in Cartesian coordinates? Yes, absolutely. But is it asking you to do that? No, no, no. You need to do this in polar coordinates, right? And do you remember what the shape looks like? Let me blow this up a little bit. You have two circles like this, right? And you're trying to find, here's the origin right here. Instead of rectangles, when you're integrating polar coordinates, what are you integrating with? What kind of sectors? Right, exactly. So you have this sector right here, but then which one are you taking away? You're taking the smaller one away, right? The bigger one minus the smaller one, right? So you need to remember how to go about doing that. Do you remember what the area of a sector is?
1/2 r squared.
Did anybody remember what it is? 1/2 r squared. Is that what it is? You guys, I'm not sensing a lot of confidence. I have Matt May moderately confident, which means I'm really scared about the confidence level of the rest of the class. So what I mean by that is, if you have a sector of a circle, if it was a perfect circle, and you have the radius, right, and you have r and r, they're infinitesimally, they're really, really similar lengths. What was that formula? 1/2 r.
1/2 squared theta. 1/2 r squared theta.
D theta, or theta. The theta value
D theta
is going to be our theta, right? Because it's going to be, you need the angle measure, right? So if you have a sector like this, Tori, that's a sector, right?
Yeah.
If you have r and this is theta right there, one thing we did long ago was talk about how you write the area of this sector. And as far as people are telling me, it was 1/2 r squared theta, right?
So just integral.
So in this case,
It's kind of a triangle.
it's kind of a triangle, exactly. It's kind of a triangle. So you have to realize which one of these is properly written. Now, there's some key differences here. Sometimes the square is on the outside and sometimes the square is on the inside. You have the big one minus the little one. So you're going to have a big sector and you're taking away a smaller sector.
Yeah.
So if that's the big sector, you have 1/2 the big radius squared theta, right? And what are you subtracting? 1/2 the little radius squared theta. What factors out of both of them? You end up with 1/2, right? You have this integral of r squared minus little r squared, and instead of theta, what's being written in the integral? D theta. D theta is like the little infinitesimal little piece. You're adding up a lot of these. That's what Riemann subs do. They glue together lots of infinitesimally small things. So you go back up here, and which two can you immediately get rid of? Which three can you immediately get rid of? You can get rid of these, right? Why can you get rid of those? The square's in the wrong place. It's outside both. What's the little radius the whole time? 4. So you can't. That doesn't really narrow it down for you here, right? Because you have 4 and 4.
Yeah, but you know
The
some
bound.
Oh, look, these are the same, right? So what's the difference between these two? The bounds. You can do this easily by not thinking of it as which one it is, which one it definitely isn't. Which one is it definitely not?
It's not 0 sine.
It's not this, right? Because where is 0 degrees?
Okay.
0 degrees is right there, and pi is right there. But does it cross there based on our sketch? No. So which one does it have to be? D.
What if you put 4 sine theta equals 3?
Yes, or you could solve it, yes.
Yeah.
I'm just trying to give you ways that you can go, clearly it's not, this is 0 degrees, right, in polar land? Is this intersection point happening at 0 degrees? No, so therefore it can't be this one, so it has to be that one. Leverage the fact that they're giving you the answer. Leverage that fact. It's not asking for any written work. It's not asking you for proof of this. You just need to get to the point where you're 99 or 100% sure and just go. Keep moving.